Okay, folks, I'm going to go over a few more problems. I had a couple more requests to go over some of these problems on this week's AP Classroom Progress Check Part B. These three, I'm going to do number 4, 5, and 8. All of these are no calculator. So let's get into it. Number 4 here, we're given the graph of G on the closed interval 0 to 10, and it tells us it consists of 4 line segments as shown above, and f is the function defined by f of x is the integral from 4 to x squared of g of t dt. What is the value of f prime of 3? All right, so the first thing I want to do here is generally find f prime of x. Oops, use a little bit of a thinner pen. All right, so f prime of x, which means I'm going to differentiate this function, which is an accumulation function. So we're going to be using the fundamental theorem of calculus part 1, which generally says if you take the derivative of an integral, those two operations cancel each other out and you're just left back in terms of the integrand. Now, the only difference here is that notice our input is a function itself, so we need to be using the chain rule. So the chain rule says the derivative of the outside function, which normally would just leave us with g of x, but in this case, it's going to be g of x squared. I'm going to multiply that by the derivative of the inside function, and again, the inside function being my x squared, so the derivative of that is 2x. Okay, so there's my general derivative, f prime. Now we can go back in and go, all right, so f prime of 3 is then g of 3 squared times 2 times 3, which is g of 9 times 6. All right, so now we can reference the graph above, which is the graph of g, to find g of 9. Now, of course, they don't make this easy for us. Notice that we have a coordinate for 10, we have a coordinate for 8, but 9 is on the line segment in between. So we're going to have to figure out what the output is at 9. Fortunately, this isn't too bad. All we want to know is what that coordinate is, so we know it's 9 comma something. Now, they do tell us that this is a line segment, so we can find the slope between 10 and 8. So y2 minus y1, so I'll do 3 minus 5 over 10 minus 8, which gets me negative 2 over 2. All right, which is a slope of negative 1. So to get to the point 9, I'm just going to go up 1, left 1, right? So going left gets me 9. Going up 1 is going to get me a coordinate of 4. Good. So g of 9 is 4. Now to just finish this up, 4 times 6, which is 24. Answer D. Cool. Let's move on to 5. All right, so using the substitution u equals 4x minus 3, the integral of x times the quantity 4x minus 3 to the 10th dx is equivalent to which of these? So they tell us the substitution they want us to use. So the first thing I would do is go, all right, then what's du dx? So the derivative of 4x minus 3 with respect to x would just be 4. Okay, so du is 4 dx. Do I have 4 dx? No, I have dx. All right, so I'm going to divide the 4 over and just say, all right, 1/4 du is dx. Okay, so let's see what our substitution works out to at this point. We know the 4x minus 3 becomes u. We know the dx becomes a 4th du. And so the problem is we still have this x left over that we haven't substituted out for yet. So what we're going to do is take a look at the relationship between u and x here. And I'm going to isolate x. So I can say, I can add 3 to the other side and say that 4x equals u plus 3. So x, divide out the 4, equals 1/4 times u plus 3. All right, so now I can put everything in terms of u. This x is going to become a fourth u plus 3. So let's write out what our integral is going to look like at this point. All right, so now we're going to have the integral. That x in purple becomes the 1/4 times the quantity u plus 3. That 4x minus 3 becomes u, so that's still to the 10th. And the dx becomes a fourth du. All right, so let's see. I have some constant multiples. I'm just going to multiply those out and move them to the very front. So 4th times a fourth is a 16th. Integral. All right, I can now distribute this u to the 10th. So u to the 10th times u would be u to the 11th plus 3u to the 10th du. And I think there is an answer that matches that. There we go, d again. All right, last one. This one's definitely the most challenging. There was a Khan Academy section that went over completing the square with a u sub. I hadn't explicitly posted an example of this yet, so this will be good to get an example up. Okay, so this is not a trivial integral, meaning we don't just know it off the top of our head. We can do a little bit of simplifying. First thing I'm going to do is factor out a 4 in there. So let's do that. So we have the integral of 10 over the square root of, I'm going to factor that 4 out, and I'll be left with 2x minus x squared, and then dx. And so 4 is a perfect square, so I can simplify that. Square root of 4 is 2. So that becomes integral 10 over 2 comes out of the radical, 2x minus x squared dx. Now the 10 and the 2 can reduce, right? 10 becomes a 5. Okay. So now we're going to get ready to complete the square. So we have the integral of 5 over square root of 2x minus x squared. So I'm going to complete the square here. It's probably been a while since you've done this. What you want to, the first idea is identify what b is. B is the linear coefficient in your quadratic, so in my case b is 2. And you want to divide that by 2. So 2 divided by 2 is 1. Then you want to square it. 1 squared is 1. That's going to be the value that completes the square. So you're going to want to add that in. But I can't add that in without fundamentally changing my expression. So to counteract that, I'm also going to subtract it off. Minus 1. And this is all under the radical. Okay? So now, this quadratic is a perfect square, meaning it will factor down to a binomial squared. And the way that one factors down particularly is 1 minus x quantity squared. And you can verify that by multiplying it out. But I still have this minus 1 outside dx. And now we're ready to make a u sub. So I'm going to go let u equal 1 minus x. So then du dx is negative 1. So du is negative 1 times dx, or I can divide out the negative 1. Negative du is dx. All right. So this becomes our u. dx gets replaced with negative du. All right, so let's write out our new integral. So it's going to be integral 5 over root u squared minus 1 du. And there's also that negative that came along with it, so I'll put that out front. All right, I can take out the negative 5, or sorry, the 5. And that'll make this a little bit more recognizable. I'm actually going to put the negative here. So I'm going to put it down here. 1 over u squared minus 1. So this is now a trivial antiderivative. And by that I don't mean it's easy. It's one that we should know. But it's also been a long time since we've done this. So just to remind you, the derivative of inverse sine is this, meaning the antiderivative of that expression is inverse sine. So what I'm going to end up with is 5 times inverse sine, of u, and then don't forget this is an indefinite integral, so we need our plus c, right? And then the last thing we want to do is replace u with the equivalent expression in x, and so u was 1 minus x, so it's going to be 5 times inverse sine of 1 minus x plus c. All right, right as I got to the end of this, I realized I made a small mistake, so I'm going to take a few steps back. So, take a look. Let me erase some of this stuff.
What is happening? Right. This is not okay.
Hey, Aaron, all right, I'm going to take us back to this point. I'm sorry. So here's what I'm going to do slightly differently. I'm still adding 1 and subtracting 1. I'm going to focus on this trinomial, and I'm going to factor a negative 1 out of there to make it this situation. And that's going to allow me to factor this down to negative x minus 1 squared plus 1, or equivalently 1 minus x minus 1 quantity squared. Okay, so that's what's going to be under my radical. All right, so that'll make this work out for us. 1 minus x minus 1 squared dx. And that just changes our u substitution to x minus 1, which makes du 1. So du dx is 1, so du equals dx. Okay, and that actually makes everything work out, where we'll get one of the answers. So integral, I'm still going to pull out the 5 of 1 over square root of 1 minus u squared du. And this is the one that the derivative of inverse sine gives us this expression. So the antiderivative of this is inverse sine. So now I'm at 5 times inverse sine of u plus c, and then replacing u, we get 5 times inverse sine of x minus 1 plus c, which is answer C. All right, folks, hope this helps.